Dear visitors, welcome to today's webinar on the design of optical sensors in IIoT applications in the special field of coating questions. So what is a customer just coming to me? The first thing he would like to have, yes, I would like to have full control of all parts 100%. That means maximum. He would like to have the maximum. And on the other hand side, the discussion is something like having this green smile on the KPI in the shop floor, which just shows me, yes, process, I'm sure on the process. Every part is correctly coated and quality is good. And what you see here, you have seen no measurements. You have just ideas on what the coating should look like. But when we take those two facts together, what will come out? An extreme complicated solution which will be extremely costly. And how now to deal with this problem and to diminish it to a solution which is able to achieve. Okay, what are the possibilities on inline measurements and what parameters do we have in coatings? So in the middle of this plot we see the coating thickness and we see which is in principle not the primary parameter. We see the real parameter which are interesting to get the application afterwards. This is of course color, this is flop index, it is corrosion, it is UV stability, it is abrasion, it is adhesion and appearance. And last but not least, everything should look like very glossy. But in fact, these parameters surrounding the coating thickness are very complicated to measure, especially when you go to inline requirements. So how to deal with it? Yes, we measure the coating thickness because it is the easiest way to get the correlation between these parameters which really are the interest of the customer. So this was just only the introduction. Now we come to the inline and online setups. So we look to this nice yellow 3D car from a computer animation. And what we are doing when we coat, we just have normally a cheap substrate and we would like to coat the final function to the substrate. It means the coating has really the effect of giving the main aim afterwards. But what has happened is that all these nice pieces and consuming products are curved, round, shaped. Everything is coming from a 3D modeling computer. So just looking to the car, which is the real complicated thing is just to coat the front side of the hood or the fender. Then we have sealing systems. That means we have rubbers where we would like to have our window going up and down and even in winter time, and you won't hear any noise from this sealing system. Of course, you have a protective coating. You have a brake disc which should look like nice and not rusty. But the real problem is when we look to the flat surfaces, so it means in the middle of the hood, in the middle of the door, yes, coating thickness measurement is easy and you have different possibilities. But the next step is that we have slightly curved situations and then coating thickness measurement starts to become more complicated. And in the third step we have these red points. But these are the real critical points. These are complicated to measure, but these are extremely important to measure. That means if you get the ever-aging of the flat surface, yes, you know in the mean value what's happening on the coating. But to really sell this car, you have to know what's going on the red curvatures. And what we found out from the 20 years we are now dealing with this job is that when we start in the beginning of these projects, the difference between the green and the red spots are very often nearly more than 90%, a factor of 2 away from each other. So just keep in mind the 20 microns tolerance, and this means you're far away the tolerance. And now how to get rid of it? So you have the classical setup with a 6-axis robot. What is the advantage of a 6-axis robot? Yes, it is extremely flexible. You could go to every point you would like to see. But in reality, you have a huge space requirement. And in nowadays applications, in nowadays factories, the amount of space which you have for the production should shrink more and more and more. We are talking about new facilities just shrinking by a factor of 20 to the normal setup. So space is a real problem, and the 6-axis robot or the 7-axis robot in a car situation needs 7 meters space. You have a complex integration. Complex integration means you have specialists for programming the robot in the beginning. You have a high level of knowledge which you need for servicing. And in the case that the system is set up, okay, everyone is here and you have the engineers just programming the robot and so on. After half a year, you have a new facelift of the car. You have to reprogram the robot. And at this stage, you found out that the specialists are gone out, and robots become extremely complicated. That means you will need a high level of well-trained staff. So what is the difference, or what is the other possibility to deal with it? The next is velocity. If you would like to have a process which is very fast, where you only have a diminished amount of time, we're talking about 1 or 2 seconds and the next part is coming in. This is of course not a car body, we're talking about like a battery cell, which we see here. Then you need a lot of sensors from different sides, because just the cell is coming in, it's stopping for 1 second, and you have to measure all the critical point in one glance. You're talking about 5, 6, 7 points. And this has the advantage to be very fast. We're talking about 1 or 2 seconds. You have a very easy possibility to integrate the sensors. You just mount it. You have a reduced amount of space. Typically we get half a meter. Half a meter is what you get, but then everything is finished. But the disadvantage normally is you have to have sensors which should be very extremely good for doing the same job. Just keep in mind the same part. Normally take a robot, take one sensor, move around, get data from the sensors. Now we have 6, 7 sensors just doing all at the same time the same job. So they have to be calibrated to each other very perfectly, which is nowadays possible but has to be kept in mind. Okay, what different possibilities do we have to get high speed and high throughput? We'll have to look to inertial system. Inertial system means if you have a very light sensor and putting it to not a 6-axis robot, to a so-called pick-and-place robot, we are talking about a factor of 10 more speed between different positions. Then you are able to get to these critical points. You have no line modification. That means the parts are just moving on and the robot is just doing some kind of pick-and-place. But it is only possible if you have a linear movement in one velocity and you have no vibrations in between. Okay, there are cases where it is possible, then it's very easy to integrate, but we still have cases where this is not possible. So the next thing is, before we talk about two-part, now we talk about two sensors. That means a multi-point. You take the same robot, just pick the part from the line, and then move it to the sensors. And of course, then you have the possibility to have the multi-sensor setup. On the one hand side, you have the possibility maybe to rotate. That means you have the flexibility which you typically have from the 6-axis robot, but you are just in a what we call an inertial system. That means no vibrations, everything from the line is just gone away for a few seconds and you could do the measurements. Of course, you have the disadvantage. In this case, you could not measure all the pieces, but normally coating process is stable over 5 minutes to half an hour. And of course, you have some CCD overhead. Okay, now we come to stage number 3, how to deal with data and how to connect the sensors, these intelligent IIoT sensors, with PLC and with databases. So the first thing, very easy, of course, is you take a USB stick, put it to the sensor controller. It's very easy, it's very safe, but it's non-automatic to put it to the database. The second step, which the system integrators like mostly, is using the PLC. We still have the PLC to run the robot, to run the line. And then we have a field bus system into it, because the sensor is communication with the PLC over this field bus. And then you just put the data over the PLC to the local database, what you see here. But the disadvantage is, for us as sensor suppliers, it's extremely complicated to service this sensor, because no one would like to have extra load on the PLC backward into the sensor controller to do checking of the sensor, because it could influence the line, it could influence the communication between different PLCs. So no one would like to have it. This is a one-way direction for data. The next thing is, of course, having a local network, and besides the field bus, you still have a second network line to put the data directly to a local database, do aggregation, do data mining, do alarming, and of course do the shop floor visualization. This is in principle what you're aiming for, but it has one disadvantage. You still have the service not automatic, and we as sensor suppliers still know that the service case is the most complicated, because in service case someone has to open the database, give the data, and then you're discussing about what could be wrong. So the real solution, or the final solution, is of course nearly the same thing, that you put the data directly to a cloud database, do the same thing like on the shop floor, aggregation, data mining and alarming. But what you have is the possibility to look to the data automatically and just tell the customer, okay, sensors are working okay, or we have to change it. And this has really a big advantage, because as more automatic you have the setup, as more pieces are inside, but normally as less workers are inside. That means they had a lot of pieces to control, and then they like to have someone who is aiding, especially on service on long-term data. Okay, when we store data and we look to coating sickness, very often people say, okay, I store the coating sickness, everything is nice. But effectively, especially when dealing with the coating sickness measurement in inline applications and online applications, you have temperatures. Everyone knows who is coating pieces, temperature is very important. So first thing, of course, for us, for the sensors, is look to electronic noise, look to optical power, everything is dependent on temperature, and look to overheating, that is of course clear. Then the people dealing with the coating material, they would like to know the temperature, because the coating viscosity, the air humidity, extremely important for wet film applications, everyone knows. Then we have the process of the droplets flying to the part which should be coated, and you know exactly that this process is strongly dependent on temperatures, on substrate temperature and air and so on. You have the film build itself, that means how flat the surface or how glossy it will, depends strongly on temperatures. And last but not least, you have to cure the whole coating thickness layers, and this is of course a question of temperatures. So why shouldn't we store all this temperature data, which we still have also in this database, to really have the possibility to analyze in error cases? And I really could tell you, most of the applications where we have questions on coating thickness start with just looking to the temperatures, and then everything is nice, because you see that something has gone totally wrong meanwhile. So we see it here. Temperatures are really, really important and easy to measure. Okay, what possibilities do we have with these coating thickness measurements nowadays? Yes, we could measure in non-cured states. That means we really could go into the line. We're coming from the quality section after the curing and just shifting the sensors into the line as close as possible to the application. And what are the major constraints? Yes, application should be automatic air conditioning, because if we have a wet film, is just dehydrating. It's typically, everyone knows it, it's dehydrating. That means besides the sensor which you are using, besides the physics, it doesn't matter. All physics which you take are just seeing a shrinking material. So that means the calibration process, I come to it later, is really very complicated. Okay, how to deal with it? Firstly, what you have to distinguish is, are you measuring really in the wet state? Are you measuring in the powder state or in the cure state? In the wet state, we decide between totally wet, that means directly after applications. Then the advantage is to be very fast, very early. The disadvantage, you really see every kind of dehydration of this shrinking material. The next step is to place the sensors after what we call the intermediate oven or flash-off oven. That means to pre-cure the material. You could not touch it, but you could measure it with a non-destructive testing. And most of the dependency from the film build is reduced. For the powder state, in the other application, that is still more easy because the non-cured powder is stable over a longer period of 5 to 10 minutes. On a wet film, we are talking about half a minute stability. And then, of course, we have the possibility to measure after the curing. But that means very late, after the full oven. We're talking about nearly 1 hour in all applications. Yes, it is a stable condition in this area. In this place, in the so-called offline place, you could measure also the other parameters which I showed before. But it starts to be very complex, especially when looking to the coating thickness. You have to resolve all the layers which you applied before. And that means I now speak not about calibration, I speak about forecast. What you do is just take all your knowledge on dehydration and measurement and temperatures and just forecast what will come out in the quality section. And that is very typical of what you have on your mobile phone. Everyone has it on his mobile phone, using it every day. You are just planning your party outside, if we are able to do it this year. By looking to the app and looking to the forecast, still you know maybe it's not totally correct, but in most times it is correct, and I plan my day, and in this case I plan my production due to a forecast. Now, what possibilities do we have to create this forecast? Because it is, of course, it has to deal with more data than before. The classical method is to calibrate the system. You prepare a part, measure it with a robot, with the automatic station, then you cure it, you put it to the quality section, they measure it offline, and then you compare these, I call it matched points, and try to do a linear calibration. That is typical classical calibration. So what is the approach without any preparation? It is just a statistical method, because you know over a small time period of about 5 minutes a coating application is stable. And then in this stable situation you have a so-called statistical Gaussian distribution of the coating thicknesses. You measure it with a robot online device, you measure it afterwards also in the quality section. And what you do is just with the standard deviation and the mean value of these distribution functions, what you see on the right lower corner, is just you match those two together numerically, and that means you make a reverse forecasting for the station inline. What are the advantages? You take standard quality data. You do not longer go into the line taking data from the line, from the station. You just put it in automatically. You have the possibility to put in a new color and do nothing like just collecting data automatically. And, which is of course very important, you have typically left side, right side, top, down questions, because you have different applicators in your roboting process and you have to know which applicator is doing which job. Okay, so now we come to number 5. This is what optical sensors could look like and what are the possibilities in the flexibility to change spot sizes and distances. So first thing, that the measurements or the spot size of the application should be related to what the customer is looking at. So the first glance, the typical, we are asked, so we are talking about a 0.5 millimeter spot size to just get the roughness of the substrate away. Then we have a region for extreme small parts. Just think about coated wires, we still have this task. Then you really go to spot sizes even down to 250 microns in principle. But that means you're very close to it. And then you have a other region which is going to very long distances when you try to avoid fluctuations between sensor and the coated part. We heard before on the Delta robots that there's another possibility to do it. Customers like to have these long distance sensors, but it has a big disadvantage on hitting the critical points, and I would state it again and again, hitting the critical points, finding them and knowing the coating thickness is the most important thing. So that is more or less something like being sure about the distance, but in reality not sure about the process. Okay, what we could do now when we try to get to this region where we have smaller distances but big areas, yes, we are raising resolution, yes, we are coming to camera or array sensors. Principle that has the advantage that you get an idea on the visual distribution, but you're really talking about much higher invest to camera and to the light sources or the active part of the sensors, because all good inline sensors have to be active sensors. It means you just put in some light or some energy and just look to the reaction. And this energy which you need for a bigger surface is just raising, of course, by the square of the length. And the other approach is what we call a swarm or multi-sensor solution. It is in principle the N-gauge solution which we see before. Just you have different geometries, you put the sensors to it, and not stopping at 5, 6, 8, you're going to 20 sensors. All the sensors fits exactly to the tasks what they have to look at. They are really hitting the critical points which you would like to know, and if the big sensor is breaking down, you have no information. From one point to the other, you have no information. If one bee of collecting honey is just away, you still will get honey. Maybe a little bit less like before. But the real thing is you take a standard sensor, put it as much as possible to your line, and you could replace them and so on. And this total setup is exactly adapted to your critical points. Okay, now we're coming to the summary. It's interesting how fast it is. We are talking about non-destructive sensors. And yes, the thickness measurement is the easiest inside the process. You have the possibility to do it step by step, because after every coating station, you would like to do what has happened. If you know coating station number 3, that coating station number 1 may be not okay. Okay, it's nice to know what could be changed. Nothing. Searching additional variables are important, and temperature is the most important. And again, you have to fit to your critical areas. Flat area in the middle, mean values is nice to know, it's easy to achieve, but will not give you an insight on the process. Okay, then nowadays we make everything which we could do with storing data fully automatic. We do this forecast via reverse calculation. This is what is standard nowadays. You have flexible possibility of statistics. You have the long-term data also, for example, on the measurement system application tests, which is also very important for the quality section. And that is for us the most important. You have full access to the service data, because in case of errors, you don't have to ask someone what you have done before. You will see it from the data, what's happened before. And when you put these first things together, of course, you could do all the classical data mining techniques. You could put or create these nice KPIs, which ends in this green smile, which you see on the first sheet. and you have the possibility to show it on the shop floor, everything is okay. You have in some applications the possibility to go to closed loop application. And the overall benefit is, of course, long-term validation of the process, your documentation, which is still raising up nowadays extremely, especially on security relevant parts, and which is also very important for the customer side, predictive maintenance. And predictive maintenance not only for wind power stations, predictive maintenance for small sensors. This is very important. And that altogether leads at the end to the point that you still have green words, not measurements, like constant, stable and documentation. And that is what the customer is looking at. Thank you for listening and see you maybe next week.